which your calculator will give you one answer, but there are actually two answers, one of which makes sense.
66.86 for 2.34.
66.84?
86.
86.
And then tangent of arctangent of 0.21 is 11.859.
0.8259?
859.
Right, there are two things here. The first one,
Is a wait, never mind.
That's too high of a number, isn't it? No?
well, given the way that the answer is written right now, yes, it is.
Degrees.
Yes, there we go, units. Otherwise, it's consumed radians. All right. So I don't have a problem with the magnitude of either of those, but there is a second answer. Now, the other answer doesn't make physical sense, but I at least want us to go into it, because sometimes when you do the arc value, I think arc cosine gets you a second quadrant angle sometimes, when a fourth quadrant angle makes more sense. Given that this is 0 going this way, this is my first quadrant, second quadrant, third quadrant, and fourth quadrant.
How do you find which one's right though? Because they're both in the first quadrant.
Oh, both of those are correct answers.
Oh, okay.
But on what other quadrant is the tangent positive?
Second?
No, it should be fourth.
Right?
Third.
Yes, there we go.
Oh, because they're both negative, right? Because like.
Yeah, it's sine over cosine, third quadrant, they're both negative. So there's another angle here of whatever 180 plus that is, so 246.86 degrees and 191.86 degrees.
And you're just adding 180 to like make
Yes.
it. Okay.
Yep. So there are four answers here. However, considering the mechanics of the problem, the thing is being shot up that way,
Not that.
the third quadrant angle means it's being file driven into the ground. So physically, the third quadrants do not make sense.
All right.
How long did it take us to solve this problem?
Not as much as later on when you do it on your own.
Yeah, 100%. I'm gonna take like an hour to do this.
So there are two solutions here. Sketching up a problem here. So one of them is a 66-degree angle, gets shot up like that and then lands. The other one's the 11-degree angle, which is gonna land in the same spot.
And they just happen to work because they both land at the same time and stuff.
Yeah, they're typically in these problems where you're trying to find the angle, there's gonna be two answers.
Okay.
Unless I happen to hit whatever the maximum possibly is. They just happen to throw in the angle which puts it at its very maximum spot, in which case there's one answer.
So the 11 and the 66 work.
Yes.
66 would be the higher.
Yep.
higher.
A quick example of why two angles work here. If I wanted to hit the, let's see if I can do this in two shots. If I want to hit the wooden spool down there, which I think four of you might be able to see. There's a wooden spool down there. I can toss this up in the air and hit it, or hopefully you get the idea.
Wouldn't the initial velocity need to be different? No, I don't understand how the velocity would be the same. If the angles are different and it lands in the same spot.
That's a good
The difference is that here you've got more horizontal for the 11 degrees. You have more horizontal, less vertical. Because there's less vertical, it's not going to be in the air as long, but there's more horizontal, so it's going to go further and it bounces out.
So the velocity is the same, you just direct it differently.
Speed is the same.
Okay.
Yep.
Oh, yeah, that makes sense.
So this is what I consider to be the hardest of the projectile motion problems, typically because people are, one, there's a certain amount of leap of faith at some point. With a complex problem like this, people get into it in physics, and suddenly they're going, all right, I can spend another half hour on this, and if this is completely wrong what I'm doing here, then I've just wasted all that time. And so there's a certain point where there's a leap of faith that I'm doing it right, I'm gonna come out with an answer that's right. And you just plunge on through.
Wait, I'm sorry, can I ask a follow-up question?
Sure.
So I can accept that the vertical and horizontal, what I'm gonna call them components, would be different for each of the angles, but yet in our chart, they're still the same. It makes sense to me that with the shallower angle, the lower angle, that you maybe need a higher, like the horizontal component seems like it should be larger than the one with the larger angle.
All right, let's work under the assumption that these are correct answers.
Right.
There are enough people who got it, we'll have faith. So let's take the 66.86 degrees. This is still gonna be 200 and negative 40. What are the horizontal and vertical? What's 50 cosine of that and 50 sine of that?
Sine is gonna be 45.9.
Cosine is 19.65.
And then 0 and negative 9. All right. So time, because acceleration is 0, I'm gonna find time using this side over here. So my time should be 200 divided by 19.65, which is, a little bit more than,
No,
Yeah.
wait, no, cause it comes out to be 0, the like 1/2 acceleration time.
sorry?
Are we using a cake formula right now?
Yeah, using the same one that we've been using here. With the acceleration 0, it just ends up being displacement is velocity times time.
Oh, right, okay. Okay, well, it's 10.17
10.17.
seconds, yeah.
So now, plug it into the same equation, except now we have an acceleration. We get negative 40 equals 45.9 times 10.17 minus 4.9, 10.17
Make
squared.
it 10.18, cause I didn't round it right.
Oh, 10.18.
Yeah, sorry.
My gut's telling me it's gonna be somewhere around negative 40, but, you know. I guess I should say, please let it be somewhere around negative 40.
I'm missing the variable that we're solving for right now.
What we're doing is showing that this, with 66.86 degrees, that we get,
Oh, we're showing that it is equal to negative 40.
Yes.
To show that it checks out, got it, okay,
Yeah.
okay.
and you got,
About negative 40 with some rounding errors.
okay. Alright. Other questions on this before we do it with the other angle? Start erasing this bit. Alright, so this is 200, this is 11 point, darn it, I erased it, what was it, 11.86 degrees?
Yes. Yeah.
Okay, so 200 and negative 40, what is gonna be 50 cosine of this and 50 sine of that?
The cosine is 48.9.
Sine is 10.276. Yeah.
Alright, so going through the exact same process, the time now for it to hit the ground is gonna be 200 divided by 48.9. So it's not gonna be in the air anywhere near as long, it's closer to 4 seconds, 4 point something. And now plugging in the vertical information, we wanna see if negative 40 is equal to 10.276 times 4.09 minus 4.9 times 4.09 squared.
It is.
Yes, all right. So looking at the two answers here, definitely this is in the air longer. It's in the air for for a little over 10 seconds, and which gives it enough time to go out that far. Here, it's not in the air as long, because the vertical is much smaller, so it's not gonna be going up as far. But because the horizontal is so much bigger velocity, or bigger component, that it has a chance to go out the 200 meters.
Got it.
I hope that was more than just a math exercise right there, but you'll be able to review the recording again and again. Share it with your family on Thanksgiving. Or for some of you, fortunate enough not to have your family there, you can send them an email. We haven't delved into the math far enough, so we're gonna do one more bit of even more grueling math, just to show you a different approach to it. We're not gonna actually solve it the entire way. We're gonna get closer, but not solve it the entire way.
Is this the hard part you were talking about?
The what we did, just solving for theta is difficult, because if you don't see this trick right here, you're about to end up in the other spot. Questions before I erase this and we do it a different way? So I have negative 40 is equal to 200 sine of theta over cosine of theta minus 78.4 over cosine squared theta. So this time I want to get rid of the fraction, so I'm just multiplying everything by cosine squared. So I get negative 40 cosine squared. All right, so this is an issue I run into again, writing a whole bunch of stuff. At what point am I going to drop one of the exponents? So what I'm going to do is I'm going to do a little substitution here. I'm going to let S equal sine of theta and let C equal cosine of theta. Just because I won't have to write as much. You don't have to do that. You can use different letters if you want. Just this way, it's easy to remember which one's which. So I have negative 40 cosine squared is equal to 200 sine cosine minus 78.4. Yeah, minus 78.4. I have an equation here with sine and cosine in it. There is the relationship we talked about earlier. I know that cosine squared plus sine squared is equal to 1. Now it's a matter of, we're going to solve for, I have two equations, two unknowns, if you count cosine and sine as different variables. Solve for one of them in this, plug into the other. So cosine squared is equal to 1 minus sine squared. And therefore cosine is the square root of 1 minus sine squared. So I have negative 40, 1 minus sine squared is equal to 200. Actually, that's plus or minus, so that becomes more difficult. So what I'm going to do here is, this is sine times the square root. We'll leave that as sine cosine, and it's 78.4. I'm going to isolate cosine here. So I have negative 40 plus 40 sine squared is equal, bringing that over, plus 78.4 divided by 200 sine is equal to cosine. I now square both sides, because I have a formula for cosine squared here, because I don't know if it's plus or minus. Alternatively, I could plug this in here, one with a positive solution and one with a negative solution. I think ultimately I'm gonna square it anyway, so I square this. And so I have all this squared is equal to 1 minus the sine squared. And then I get rid of the fractions and end up with a fourth order polynomial. Now conveniently, if you actually work through this, what you're gonna end up with is let's make sure I'm not lying about this bit. All right, so that's, yeah. So you're gonna end up with something times s, the sine to the fourth power, plus something times s to the second power, plus some constant is equal to 0. Mathematically, there's 4 different values for sine. When you do the arc sine, there's gonna be 2 answers for that, so you got 8 potential answers doing it this way. Of which, well, obviously, look through that, the angle is gonna be around 66.86 degrees, somewhere around 11.86 degrees. But dealing with this, how do you solve this fourth order polynomial? I offer it, ask you, how would you solve this fourth order polynomial?
I was gonna say long division, but that doesn't work here at all.
Yeah, that, potentially you could get lucky and do it that way, but I don't think.
Yeah.
Could you break it up into 2 polynomials?
It had an incredibly difficult way of doing it.
Okay, so let's not do it that way.
Yeah, it's not a nice problem. But there actually is a relatively simple solution that's definitely within what you can do. Let's do a substitution here. I'm gonna use, I used z before, how about if we just use w this time? Let w equal s squared. So I end up with whatever that is times w squared plus something times w plus something is equal to 0. I have a typical looking quadratic. You now use quadratic formula, solve for w. Once you have w, you'll do the square root, don't forget plus and minus solutions, and you'll end up with some values for sine. So at that point, you'll have 2 solutions for w, 4 solutions for sine, and then you'll do an arc sine. And you'll feel pretty good when you come up with the right answer.
If
If that
When?
actually even
When?
happens, yeah.
Now, I have done this on tests before, 151 tests, problems like this. With the thought of, oh, this will be fun.
This will be fun.
For who?
Yeah, for you.
Think of the tears of joy streaming down my face when all of you get it right. Now, I do accept this is probably excessive, considering there's a time limit how long you have to take a test.
And you had to erase the board like 3 times, so.
Yeah, I'm gonna need 2 sheets of paper for this.
I will supply paper if you need it. All right, questions on the gloriousness that is this problem?
Like, I don't even know where to begin to ask a question, so I'm just gonna leave it.
I would recommend it, that you, let's just say, even though it's not necessarily my intent, sometimes I will throw a problem like this onto a test now, except I'll write in something like, I think this is the hardest part, this is the hardest question on the entire test. Just so that, take the challenge or not, but.
What are they called, the trig identities? Are those like something that we should just have like on the back of our hand, kind of thing?
I don't remember what I've done in the past in terms of tests. I think I've written SOHCAHTOA at the top. Sine squared plus cosine squared equals 1. I don't know if I've written that on the top or not, but it's the type thing that,
You really should.
hey, what,
Should
There's
just,
some equation you had with sine and cosine, could you
okay, yeah,
find out?
for sure.
Are you gonna include, like, if we have a problem that deals with needing all the trig identities, would you include that on the test? Like at the top? Or-
I should, and if I don't, just ask.
Okay,
Or if you wanna mess with their heads and you know it's not there, ask for it anyway.
Yeah.
Have people wonder.
I remember some, but not all of them, cause I was beaten into it, you know, in trig. They really, they spent like a month on it. It was ridiculous. Not specifically like those, but the whole thing in general, you know, you spend a whole month on just trig identities.
As ensure that these two sides are equal to each other?
Yeah, or like sine squared plus cosine equals, squared equals one, you know, the secant, cosecant, cotangent, all that stuff. It kind of melded together.
And speaking of melting together, I'm about to put it all on the bottom of this. Any questions before I erase? Close enough. All right. So some of the stuff from chapter 3 is stuff that we did early on, like breaking vectors up kind of thing. I'm just doing a quick check to see if there's something I've forgotten. That, and that. Let's talk about, you know, first test, things like that. This is the output.